right, what we are doing today is we're looking at the area of a sector and the measure of an arc length. Hannah. Yep. So first off, we need to talk about what is a sector. If we are looking at a sector of a circle, then we are looking at a piece of that circle, like a piece of pie. It has to be formed by a central angle. That means the vertex of the angle has to be the center of the circle. And we are looking at the area of this shaded piece. That's called a sector of the circle. So, definition sector of a circle is, what's that?
Oh, like it is like about a 360, you can measure it through a 360.
It is. Yep. And we can talk about how do you find the area of that sector right now because you brought it up. The area is going to be what fraction of 360 is that angle? So you go x over 360. And that is the fraction or percent, you might say, of the circle you are working with. So you are working with x 360th of this circle. Then what you do is times that by the area of the circle. How do you find the area of the circle? Pi times r squared. So we're going to take that times pi r squared. That will be the area of this sector with a central angle of x. So definition of sector, it is a region of the circle formed by two radii. I could say that's cut out of the circle by two radii. And this is area of a sector. And then along with this idea, we can take a look at the endpoints A and B. And we can talk about what is the length of arc AB. So along with this, we are going to be talking about what is the length of arc AB. So arc length is going to be then a fraction of the circumference. What fraction of the circumference is arc AB? Well, it depends on what the measure of x is. We know the full circle has a measure of 360, so this is going to be x over 360th of this circumference. When you take the earphone out of your ear. So our arc length then is going to be usually with a letter S. What did they do here for arc length? Just length of arc. So the length of arc AB is going to be then x 360th of the circumference. And our circumference, how do we find circumference of a circle? 2 pi r. Now, we're going to be using these formulas, and because of what we can do with drawing segments or chords inside these sectors and looking at triangles and so on, we can make this be harder or easier, depending on what we're working with. So let's look at a few example problems. First off, easier example problems. Page 453, the written exercises. Let's take number 5. Let's not do number 5, let's do number 3 to begin with. I have a measure of angle AOB is 120. And then the radius is 3. So we want to find the area of the sector, and we want to find arc length. Number 3 on the green box. On page 453. Let's figure it out. So our area is going to be 120 over 360 times pi r squared. Pi times 3 squared. Now 120 over 360 is a fraction that reduces, so I'll reduce it first. That is 1/3. So 1/3 times, and 3 squared is 9. 9 pi. So I can now reduce 1/3 with 9, which gives me 3 pi for the area.
Yeah.
Now for arc length. Our arc length then is still going to be 120 over 360, but this time times 2 pi r times the circumference. So times 2 pi times 3. This then is 1/3 again, 1/3, and this is going to be 6 pi. Reduce the 1/3 with the 6, and we get 2 pi. So this is the first idea. Let's go ahead and look at number 11. On number 11, it tells us that the area is 10 pi. Area of the sector equals 10 pi. And then it tells us that the measured angle AOB is 100. We are going to plug into this same formula right here. This time, we know the area is 10 pi. So we have 10 pi equals 100 over 360 times pi r squared. When we reduce 100 over 360, take out the zeros and you have 10 over 36, which reduces again by 2 to 5 over 18. If you divide by pi on both sides, you make your problem look a lot easier because it really just takes out that pi on both sides. Now the question is, how do we get rid of that 5/18 to get the r squared alone? Multiply by reciprocal. So multiplying by 18/5 on both sides. Notice the 5 and the 10 reduce, leaving a 2 and a 1. So 18 times 2 is 36, and here they both reduce, leaving r squared. 36 equals r squared then. So r equals 6. Now if they wanted to know arc length, we could use that to help us find the arc length.